you know who you are. Someone said 2 to 7 questions, 3 to 5. Is that off the new packet that we started, the 2 pages?
Yeah.
Yes?
That was my 2 to 7.
Okay, so off of there? Okay. The 3 to 5, similar thing? Okay, perfect. And I think that's covering formulas. And so one thing I want to point out really quickly, when you say formulas like this, right? This is a formula, but also what would this be called? Equation, right? It's got an equal sign. You don't have to change the way we approach problems like that just because it's a formula with multiple variables. Does anyone remember the specific name of equations with multiple variables like this? It starts with an L. Literal. They're called literal equations, is all it is. Just we have multiple variables instead of just one. 6 and 7 again, how to make a table of a graph. Do we get a grade for these bell ringers? And no. Alright, I'm calling that person out. Harold. It's funny, like, y'all need to remember, a grade doesn't give you learning. The point of these bell rings is always so that you can learn more. I need to see what questions you have so I can help you be successful. And you need to pay attention to them to learn from your mistakes. Struggle number 13 with transformations review. Okay. We've been doing this week. Alright, so here are the slides. I think I left it over here. So, we'll start going over questions. If I miss any of the questions that you asked, or you have another question as I go through things, let me know. I assume no one has any latest assignments to submit. If you do, get it out. I'll come and collect it later. So, quick note about solutions to the recent practice and review. I showed y'all last night, or not yesterday. Not last night. Yesterday I showed you that I uploaded solutions to all the transformations practice on Schoology, right? Did anybody go to look at that? Okay.
I did what you said.
Did you, I assume you couldn't see it when you looked on Schoology. Did you have to download it? When you downloaded it, could you see all the notations I made? Okay. So, you have to download those PDFs, right? So if you look at it on Schoology, for some reason it's not going to show all the stuff I wrote on there. But if you download those PDFs, you will see a lot of notes, right? Not just final answers, I have justification on there, the evidence for why I made the claims that I did. Now we're going to look at our questions from Bell. Oh, and then this review that we are working on right now, I actually uploaded that also. I know I uploaded it for third block. I can't remember if I uploaded it for y'all or not. I will have it uploaded this block if I don't already have it. But all that review that you have, again, answers are on Schoology, and along with evidence for any claim I make. So use that to help you study tonight. So let's look at the questions from bell ringers. So we don't need any of this or that. Didn't need that. Okay, so number 2, I need y'all to pay attention to this. What is number 2 asking?
Identify the type of function.
The most common response that I saw on students, or let me reword that. No, actually it was the most common response, and it was also the most common incorrect response, is I saw a lot of students talking about the factored form, the vertex form, and the standard form. But I need you to remember, when we say factored form, and standard form, and vertex form, that's just a couple of the words. What should you end that with? The vertex form of what?
Quadratic.
Of a quadratic function. Standard form of a what? Quadratic function, right? Are these all quadratic functions?
No.
No, I specifically said the type of function for a reason. You need to look at the type of function that you have there, and so then you need to be able to justify and explain. For example, when I look at B, what type of function is B? Factored is not a type of function. It's a quadratic function. How do you know?
Because it's in factored form and it has it has our roots.
There you go, right? It has 2 roots, it's in factored form, so we know it's quadratic, right? But the question I'm asking is, what type of function is it? It's a quadratic function. We want to notice things like that. By the way, Gerald, it might be helpful if you have, Gerald, please stop writing on the desk. You have plenty of papers to write on to help you take notes and things like that. Do you have this sheet of paper out? Okay, that might be helpful to help you study. Omar, do you have yours out, taking notes? Okay. So, keeping that in mind, right, I don't want to give you all these answers because I do want you to think through it. Work on that with your small group, discuss, and Ms. Courtney or I will be more than happy to help you make sure that you have the right answers after you've thought through it. I need you to remember, me giving you the answers does not help you actually learn. You thinking and struggling through it a little bit, that will help you learn, and then we will check it, and we may not tell you the right answer right away. We might ask you some questions to do what? Well, to get you to think. Because on your test, you're going to have to think. You've got to be able to think. All right. Why did I skip 3 through 7? Are those slides in? Didn't mean to skip 3 through 7. So let me fix that really quickly. Duplicate. So I have that review open. No. Alright, sorry for this. I will get this fixed in just a second. Alright, so 3 through 7. Again, I'm not going to work through all 3 of these, or all, what is it, 5? I'm not going to work through all 5 of them because you need some time to think as well. But I'll look at one of 3 through 5 and then look at 6 or 7. And probably not finish all the way because I need you, again, to be able to think. So, slideshow, play from current slide. So let's look at this. I need you to fundamentally remember, yes, these are literal equations. But what are some of the most basic principles of solving an equation? I need everyone to pause. I need to make sure you all understand this detail. Huh? Okay, so PEMDAS is just an abbreviation, but that's to help you remember the what? Order of operations to what? To not to solve. That's the issue. The order of operations is to help you simplify an expression. We're trying to solve things here, which means I need the inverses. Okay? Realistically, I would pretty much do the inverse of simplifying, do the inverse of the order of operations to simplify. Right? Well, so y'all are skipping some of the most important ideas. I'm not going to finish this one all the way out, but looking at it right here. Okay, so say again. Oh, I thought you started to say something. You said earlier multiply by t? Okay, but why am I multiplying by t? This is a critical idea that a lot of us are missing. Something to do with the what?
The reciprocal.
Okay. What were you talking about? That's what I want you to hear. What did you say again? Create the one. When you solve equations, you need to create either a 1 or a 0. When are we trying to create ones? Anytime what operation is already there? Division or multiplication. You're trying to create a 1. Anytime you have addition or subtraction, you're trying to create a 0. So when I look at this, yes, I'm going to multiply by t. Right? Because what is this fraction bar again? Division. And so what is the inverse of that division? Multiplication. And we want to notice, what is t divided by t?
1.
1. That's not me just crossing it out every time. I write a 1 there because the whole point was to create a 1. That's it. Now, I will also point out, can I just magically multiply the right-hand side by t? No. So what else do I need to do? I need to do it to both sides. And I need y'all to hear me clearly on this. A lot of students, I've even heard students in my classroom say this recently, they're like, well, I need to move t to the other side. You're never moving t. You need to get that outside of your head. Because if you move t, you're focusing on the left-hand side. It's not about the left-hand side here, it's about making a 1. And whatever I do to one side of the equation, I have to do to the other. Does anyone remember what those are called? What I do to one side, I have to do to the other. It's an important concept. That's properties of what? Well, so inequality means not equal. So equalities.
That's what I'm.
Yeah. Now, is this an equation? So I'm using a property of equality. Whatever I do to one side, I have to do to the other. Why? I want an equivalent equation. This new equation, it looks different than the purple equation I started with. But is it telling the same story? Yes. So I needed to create a 1 because I want you to notice, what is w times 1? See how I was able to get that w on its own? So I had to create a 1 to do that. Now I can continue this to solve for p. Notice I'm multiplying, so what number do I need to create?
A 1.
1. Okay? So I'm not going to continue from there. I want you to think through that, but I do want to look a little bit at number 4 to help us understand some important ideas. So let's look at number 4. One thing I will point out is, and I saw students struggling with this yesterday, and I can't remember if I told a small group in here or a small group in second block. What I would do for you, if you are struggling with solving these equations, first off, identify the variable that you are solving for. And I don't just mean kind of look at it in general. What's an easy way to visually make sure that you are focused on the variable that you're solving for?
Highlight it.
Say again?
Highlight it.
You can highlight it. What else could you do?
Underline it.
Underline it. I'd even go to the point of what?
Circle.
Circle it. I would box it. I don't know why, but I like the box. I don't care. But now I've identified the fact that I'm solving for W. And that's important, right? Because what's happening to W right now? Being multiplied by 2. Then after W is multiplied by 2, that 2W is added by 2L. And remember earlier Caleb actually talked about using the order of operations? I told you with solving, I'm basically going to do the inverse. You're supposed to do multiplication first. I can't multiply those. But I could undo this addition. Remember when multiplying and dividing, I want to create what number? 1. When I'm adding and subtracting, I want to create what number? 0. So what am I going to do to that 2L? Subtract.
0.
Not subtract 0. I'm going to create a 0. 2L. Notice, what is 2L minus 2L? Anything minus itself is a good old 0. Notice I didn't just mark through it. I showed the fact that I created what number? A 0. And I have to do it to the left-hand side using that property of equality to create an equivalent equation. Right? You got to remember, I can't change the equation in its nature. I have to make something that's equivalent. It looks different, but it's effectively the same. Now, this is what I want you to recognize before I stop here. I wanted to create a 0, because what is 2W plus 0? 2W. We're trying to create those zeros and ones because those are the identities, so that when I have a 0 over here, well, that doesn't matter. It's just 2W plus 0. Okay, that's 2W. And then I continue solving from there for W. Don't make that more complicated than it has to be. Think about how can I make a 0 or make a 1. What are your questions before I let you continue to work on those from here? Once, twice. I was going to talk about an important detail with 6 and 7, but I'm not going to start it like I did the others. Okay, 6 and 7, I need us to look at this. Once again, I'm solving an equation, so what am I trying to create? A 1 or a 0, that's it. And you got to know when to create a 0, you got to know when to create a 1, but you create those 0s and 1s, that's it. Focus on that in your properties of equality, you're going to be okay here, and I'll check on you. The one thing I want to point out is, if you're looking at number 7, what is something new that's happening to x there? It's being squared. The only thing, and I'm not working this one out for you, the only thing to remember, if you have something squared, you should get to x squared equals something by the end. What is the inverse of a square? I thought division was the inverse of multiplication.
Square root.
Say it again.
Square root.
Square root. You need to remember, ladies and gentlemen, inverses only have one inverse. The inverse of multiplication is division. So the inverse of division is multiplication. The inverse of a square is a square root. So the inverse of a square root would be a square. Inverses only affect each other. So we don't want to divide here, we want a square root. And so don't forget what a square root means. First off, it's the inverse, so that's going to cancel this square out. And it's actually going to make the exponent, anyone know what it makes the exponent? It makes it a 1. We're still making 0s and 1s, just in different ways. Okay? So x to the first. And we've done a little bit more with square roots recently. What are we asking when we take the square root of a number? Well, we're going to get to that in a second. But I'm just saying, what does a square root mean? Okay, so what we're asking is, what number was multiplied by itself to get, in this case, what number? 64. Right? What was multiplied by itself to get 64? Right? It's the inverse of a square, and a square tells you to multiply a number by itself. And this is important, because if you type in the square root of 64 in the calculator, what do you get? Somebody pick up a calculator. A couple people, please.
8.
Type the square root of 64 in that calculator. 8. Can we confirm?
Yeah.
Got a second?
I got 8.
You got 8 as well? 8 as well? Okay. And so that should make sense. Is 8 squared 64? 8 times 8 is 64, right? Is there anything else that I could have multiplied by itself, though, to get 64?
Negative 8.
Say that again?
Negative 8.
Negative 8. Remember, and that's what Caleb said at the very beginning there, you need a positive and you need a negative, right? And it's not random, it's because what I'm asking is, hey, what was squared to get 64? Well, an 8 could have been squared to get 64, and it also could have been a negative 8. And do you know which one it was?
Oh, both of them.
Really, it's either one, we just don't know, so we have to report both of them. Okay? That's the only thing to keep in mind when you have a square. Everything else, though, is the same. We're creating what two numbers? 0s and 1s. That's it. Focus on those ideas. Think about your additive inverses and your multiplicative inverses. Any questions there before I continue a little bit? I think the only other question was some students were asking about making tables from graphs to help you. As a clarifying detail, were we talking about something like 14 or something like 9? I don't know who that was. I didn't look. But if you were the person who asked, were you talking about number 9 or something like 9 or something like 14?
Probably 14.
Did you ask that question?
No, what was the question?
So, on the bell ringer, someone asked, not that, where's the bell ringer?
Right there.
So right here, how to make a table of a graph. That was you? So were you referring to something like number 9 or something like number 14? 9, okay. So remember, in general, all that not all I'm asking, when you make a table, you just have to make sure that you identify points that are on clear intersections of the grid. So watch my finger and tell me when to stop, because I have a point that's a clear intersection of the grid.
Stop.
Okay, so that is a point. And so I've got an x, I've got a y, and the x is 0, the y is 2. Okay? Tell me when to stop.
No.
Okay, so 1, 2, 3, 4, 5, 6. So the x is 1, and the y is 6.
The next one
Okay.
is 18.
And so I continue, and I get all the way up to here.
Uh-huh.
And that's all you have to do, is you have to be careful that it's the intersection of that grid so that we know exactly what the number is. Now that you have this, what can we pay attention to and notice is happening?
The rate of change.
Remember, the tables are great for rates of change. And so some students, so don't blurt it out yet, some students may look here and say, well, that's plus 4. But is the next set plus 4?
No.
No. So that's not constant additive, and so we have to stay flexible. Instead of thinking about addition, maybe we attend to multiplication. What could I multiply 2 by to get 6? Or 3. What could I multiply 6 by to get 18?
3.
So remember, what that is called is my constant factor. It is the, so remember, the constant factor is the name for what were you calling it, Ishmael? The constant multiplicative rate of change. Well, so remember, with a linear function, we have what type of rate of change? Constant additive rate of change. Do you remember what the name for that constant additive rate of change is? Non-linear rate of change. So, anybody remember what the name of that constant additive rate of change would be? So, constant additive rate of change is the type of rate of change, but there was a very important name for it.
Exponential.
Not exponential. Y'all just trying to say things. What do you know about a linear function? Constant additive rate of change. What else do you know? We are
Slope.
always looking at. Say it again.
Slope.
Slope. Remember, these slopes, so if I'm coming way over here so that I'm not mixing things up, that's the equation of a line, right? Where in that equation could you see an idea that is a constant additive rate of change or repeated addition? M times x. Remember, that multiplication is repeated addition, which is why this m is my additive rate of change. And what is m? What are we referring to? Slope. And that's how we calculate it, but what are we referring to? We're talking about slope, right? So don't forget, right, there is the type of rate of change, but then we have names for those rates of change, right? So it is a constant multiplicative rate of change, and we call that a constant factor. That's the name. Just like this function has a constant additive rate of change that we call slope. It's just the name for that type of rate of change. Does that make sense? Those are the only ones that really have a name for the rates of change. Kelsey, are you good with how to identify a table off of a graph? All right, the last question I think I saw was number 17. Did I skip number 15 in the numbering? I think so. It happens. I will say I think number 17 is probably the most difficult here. And I'll go ahead and tell you, because this would be one of the highest level questions on the test. But the basics don't change. You can still get a lot of good points off of this if you pay attention to things that you know. What things do we notice here?
Absolutely.
Remember, if you're going to do anything, you got to start with the type of function, right? So the type of function is absolute value. And so what's the general absolute value equation?
F equals absolute value.
What are the symbols for that?
The two lines.
The two lines around the x, right? Absolute value of x.
It would matter if I put f of x or y.
So what is the difference between f of x and y?
The f of x is the output.
Well, and y is the output as well. But literally it's just function notation versus using a y. And so it doesn't matter a ton. You actually just need to consistently think about both at the same time.
I think it's easier for me like that. I get confused for some reason.
That's fine. Okay, so you don't have to, but remember you can always make a table to help you out. And don't forget, what do we mean by an absolute value?
The distance from zero.
Every time. How far is -2 from 0? How far is negative 1? 0?
1, 2.
Got real loud real quick. Alright. And so you can graph it. And you can make a table for the transformed function, but the graph, remember you can always look at both at the same time. Just right away, what should you see in this graph? What's happened to that parent function?
Reflection.
Scoot over.
Okay, so we're going to talk scoot over a second. Which direction is that reflection though? We need to indicate that.
Vertical.
So remember, what are the two directions? How would we talk about them?
So vertical reflection down.
Vertical or horizontal. So I'm just saying it's a vertical reflection, right? So you would want to make a note here, vertical reflection. And so knowing that it's a vertical reflection, what do you know you're going to do to the equation?
Multiply.
Multiply by,
A negative.
where are you going to multiply by a negative? Well, remember we're talking about that equation, right? So it is the y's that were multiplied by negative 1, but in the equation, where's that negative going to go?
On the outside.
Outside main operation. How'd you know that, Caleb?
Yes.
It's not really good. I know it. Don't explain it.
If you can't explain it, you don't know it as well as you need to. Who can explain why it's going to go outside that main operation?
Because the y's, vertical is on the outside, horizontal is the inside.
Right. That's all you have to say. The vertical transformations are always outside the main operation. Right? That's it. And then Jakila said, scoot. What's the more mathematical,
It's little
precise word for that?
Translate.
transformed over.
Close.
Translate over.
Translate. Remember, dilations, reflections, translations, those are the transformations. The specific, when you're talking about scooting over, that's a translation. Does anyone know which point is easiest to see the translations in? Huh? The minimum, right? That point kind of in the middle right here? Because that's going to end up here. So what translations do we see?
It went up 1, 2, 3, 4, and
So-
over.
I want to pause and I want to emphasize this. Hold on, you're okay. But notice how, and students do this all the time. And it's not just you. I went to a PD on Tuesday and teachers did the same thing, which is why y'all do it. You notice how you say up and you say down? But then magically, when it's horizontal, what do you always say?
Left to right.
Y'all don't say left or right. You say
Up.
over.
Up.
But over is really talking about left. What's y'all's left? Left versus right. Just like you say up and down, say left or right. It will help. So translation up 4 and
Left 1, 2, 3 times.
left
3.
3. Right? And so notice like I identified how I'm going to write that in the equation for vertical reflection. If it's up 4, right? Outside main operation. What am I going to do outside the main operation?
+4.
Plus 4, right? It's translation. So I know that outside the main operation, I'm going to be adding, because translations are always adding or subtracting. Every time. Left 3, that's horizontal. Well, so a left 3 would be negative, but what happens horizontally? We always need the right. So it'd be +3. And so that's great to notice, right? It's left 3, right? And this is why it's important to justify, because that could be a small mistake depending on your justification, or I just go, I don't know what they were thinking, right? They just completely missed it. So inside or outside main operation? Inside, it's horizontal. So inside main operation, and we're going to do +3 as well, because that's the additive inverse.
And so when you write it in the form, it'll be y equals, or f equals.
Okay, so f of x equals,
The absolute simple. The line is +4. Oh, I see it. Yeah. And then add the +4 outside.
okay, so we need the horizontal and the vertical. Anybody want to push back on that, or are we all good?
So it's supposed to be swapped.
Say that
You
again?
need a negative in the front.
We need a negative in the front, wasn't there a vertical reflection? Okay? Now, how could I check to see if my equation is correct?
Plug it
What do you mean plug it in?
So put it in the calculator.
Okay, so you could graph that on the calculator if you have a calculator portion of the test. What if you didn't have a calculator portion of the test? I'm just asking a question. Remember, every point on that graph should make this equation what?
Sure.
Does it matter which point I use?
No.
No? So I'm just gonna use this point right here, 1, 0. I always like to use a 0 in some way. So when I do f of 1, right, so I substitute 1 in, what should I get out? What point was that I used?
Zero.
Oh, 0.
0, right? So f of 1 should equal 0. So let's substitute a 1 in. Negative, absolute value of 1 plus 3. Plus 4. Alright. And then from there, oh sorry, that's not a 1. Why don't let me make these mistakes? Isn't that a negative 1? Man, sorry. Mistakes happen. Check yourself. Alright, so negative 1 plus 3. So negative 1 plus 3 is 2. And we're taking the absolute value. So how far is 2 from 0? So it's a negative 2 plus 4. What does that give me? 2. So, did that work?
Yeah.
What were we supposed to get?
Oh, no, it didn't work.
No, it didn't work. So I'll tell you this. First off, if you manage to check this and you say, hey look, I know I got some of these details right, but I can see that the equation's not working correctly and you don't know how to fix it, you can still score high on the rubric because you're still telling me or showing me that you understand things. Anybody know what one mistake we made here? You can see it most easily in the graph.
You didn't use a point.
You see this point and this point? See how it's going up 1 and to the right 1? We all see that detail? To go from this point though to this point, how far do I have to go down?
Negative.
Notice how horizontally it's the same amount, but vertically it's not 1 anymore. First off, it's negative, which makes sense because it was a reflection. And that 2 is because it was a vertical stretch. That equation would have worked. Now, I will say that we're going to work on stuff like, well, one, if you have one question like this, it's going to come nowhere close to killing your score. Like, a question like this might make a difference between 100 and a 99 or 97. If you have two things like that. And again, you can still score pretty well on the rubric, but notice that would put a 2 through here, and that would put a 2 here. What's negative 2 times 2? Negative 2 times 2? Negative 2?
Zero.
Negative 2 times 2.
Oh.
Negative 4.
Negative 4, thank you. And what's negative 4 plus 4?
Zero.
Does that give me the correct output? That was the only issue we're missing. So that's what we want to notice. And literally, like, notice how this is a much steeper graph than this one? That's a telltale sign that there was a stretch in there as well. Okay? As I said, that would be the most difficult that you would have to see at the worst. You would see that on the test. Alright, at this point, I want you all to get some practice working within your small groups. Do you have any burning questions now that we've gone over some of these things before I have you work? Going once.
No.
Going twice. Sold. Remember, as you work within your groups, if you ask us a question, what's the first thing we're going to ask you? Have you talked to your group yet? Talk to your group first. If no one in the group can answer the question, I'll be more than happy to answer the question, because that means everyone's got some kind of question going on. If you've talked to your group and that someone explained it but you still don't understand, cool, then I will be more than happy to explain it. I will be trying to keep track of different things that students are writing down to help you improve your understanding and make sure you're actually doing it correctly. Let's go ahead and get to work. Be quick.